Hyperbolas day 2, just a reminder from before, A always comes first. Okay, as the usual format, we are going to find our equations through the use of completing the square. You're going to have to be very careful today because with the hyperbola you're going to have a negative, and we're going to have to factor out that negative every time, or else your problems are always going to be off by the value versus addition or subtraction. And you'll see that very quickly as we get through this problem. So the positive variable is the first variable that you write. Although it's not necessary, it just looks better from an equation standpoint when we do put this in standard form. I'm going to go ahead and move that to the other side. Okay, now remember, it's always critical for you to factor out. You got to factor out the value that's in front of each of your squared terms, the coefficient in front of your squared terms, if it is not equal to 1. So the y squared term is fine. So it's going to be y squared minus 14y plus 14 over 2 squared. And there's your first completed square. Now the important part here is that I'm factoring a negative out of this group of numbers. This is the part you're going to make a mistake on if you're not careful. So that means it's minus positive x squared plus 18x plus 18 over 2 squared. Alright, now that means that the value that I'm going to use to balance will be 36 plus 14 over 2 squared minus, because I've got this value that I added and this weight right here, this weight of negative 1, minus 18 over 2 squared. So when I simplify all this, I get y minus 7 squared minus x plus 9 squared equals 4. I'm going to divide out 4 throughout my entire equation, and that gives me my familiar standard form of my hyperbola. Alright, now I'm going to draw this guy. So we're going to go left 9, up 7. There's my center. Since it's 4 all around, I'm going to go left 2, down 2, right 2, and up 2. Draw my fundamental rectangle. Use that to sketch my asymptotes. And use that to create my hyperbola. Y comes first. That means it's going to be a vertical transverse axis here and here. This is my conjugate axis, these are my vertices, and my hyperbola is ready to go. Question number 2. Y squared is positive, so I'm going to go ahead and write that first. Minus 6y minus 9x squared minus 36x equals 36. Y squared minus 6y plus 6 over 2 squared is my first group, minus 9 times positive x squared plus 4x, because I factored out a negative 9, plus 4 over 2 squared is my second group. That equals 36 plus 6 over 2 squared minus 9 times 4 over 2 squared. Simplified form, y minus 3 squared minus 9 times x plus 2 squared equals 9. Divide out your 9 to the other side. Y minus 3 squared divided by 9 minus x plus 2 squared over 1 equals 1. We'll start with our center, which is at -2, +3. We will go up and down 3 units because that value of 9 is underneath the y. So we're going to go 1, 2, 3, 1, 2, 3, left and right, 1. Draw my fundamental rectangle. And from that, sketch my asymptotes. Again, y comes first, so I'll be sketching my hyperbola off the top and bottom edge of my fundamental rectangle. This is a vertical transverse axis. There's my conjugate axis. Remember, the slope of your asymptotes is found by using rise over run, so the slope is up 3 over 1 or down 3 over 1. So I've got a positive or -3 on the slope of my asymptotes. Alright, question number 3 and question number 4. More practice, but without the graphing. We'll do number 3 together. You guys will complete number 4 on your own and bring that back to class to discuss your solutions with your group mates tomorrow. This time the x squared term is positive, so we'll begin with that. That means that this is going to be a horizontal transverse axis because the y value will come second. Alright, so that's going to give me 4 times x squared plus 8x plus 8 over 2, excuse me, plus 2x plus 2 over 2 squared minus 9 times positive y squared plus 6y plus 6 over 2 squared, and that's my second group. Remember, I factored out a -9 from the entire group. That is why the 6 became positive. 113 plus 4 times 2 over 2 squared minus, remember we got our -9 here, that's the weight, 6 over 2 squared there. Simplifying this down, I get 4x minus 1 squared minus 9 times y plus 3 squared equals 36. Divide out 36 to both sides, and the final answer in standard form is x minus 1 squared minus y plus 3 squared equals 1, and this one's over 4, and this one's over 9. Your center of your hyperbola is located at 1, -3. The value of A on your transverse axis is 3. The value of B on your transverse axis is 2. And if you add those two together, you get 13. Therefore, the value of your focus is going to be, or the length from the center to your focus is the square root of 13. Like I said, be prepared to share question number 4 tomorrow in class. Question number 5. Alright, we'll be writing in general form, so we're going to start with the standard form. You've got to be a little bit observant here before you begin. because this value on the major axis is in the y plane, the y value, that means that the major vertices A are going to be underneath the y value of your hyperbola. Now, an easy way to solve this problem and really understand what you're looking at if you're confused by my explanation is, of course, to simply sketch a picture of this. And that's what I've been focused on the entire time. So please, if you're confused as to which of these values comes first, sketch a picture of this. Remember that your hyperbola comes off the major vertices. Draw your hyperbola off those major vertices, and then you'll be able to get your equation from that. Okay, now an easy way of doing this, for me, is to get a common denominator that is common among all three of these denominators. Notice that there's a denominator here even though it's not written. So my common denominator, if I multiply it all the way through, will eliminate each one of the denominators that are currently there. This is a very useful way of solving rationals, and rationals are coming up very soon. So that is the reason why I chose to use this as my method for simplifying this into general form. We'll talk more about this tomorrow, so if you have any questions, please do not hesitate to ask. So if you'll notice, out of my common denominator here, the 9's cancel, which gives me 25y squared. This common denominator, the 25's cancel, which is negative 9x squared. And then here, neither of them do, so that means that I multiply them together to give me 225. The last step to place this in general form is to move the 225 to the other side of the equation. 25y squared minus 9x squared minus 225 equals 0 is the general form of the hyperbola in question number 5. Alright, again, you want to sketch a drawing of this to see what you're looking at so that you understand which of these two it is. So we're going to have y minus 2 squared minus x plus 5 squared equals 1. The distance here is the length of the major axis. That's 2a. So you divide that distance by 2 to get 3. 3 squared is 9. The distance here is the length of the minor axis. That's 4 units. Divide that by 2 to get b. b squared is 4. Again, I'm going to employ that tactic of common denominators to help me cancel out all of my denominators. So I'm going to multiply 9 times 4 throughout the entire equation. So that means the 9 cancels here, giving me 4y minus 2 squared minus 9 times x plus 5 squared equals 36. Now we have to use order of operations here, and that means that I will be multiplying out these perfect square trinomials before I distribute the 9 and the 4 into the equation. So I get 4 times y squared minus 4y plus 4 minus 9 times x squared plus 10x plus 25 equals 36. Now I can distribute the 4 and the 9 throughout the parentheses and give me 4y squared minus 16y plus 16 minus 9x squared minus 90x minus 225 equals 36. I'm going to subtract the 36 to the other side and combine all of my like terms. Once I've done that, I am in general form. Y squared minus 16y minus 9x squared minus 90x minus 245 equals 0. Please be prepared with question number 4 and any questions you may have concerning hyperbolas day 2.